And when we worked through it, we actually came up with a pretty good idea of what we needed to do. We needed to find the maximum of this volume function we came up with. It was volume was x, y, z. Right? We need to find the maximum of that. And what we knew is that we were restricted to this ellipsoid, right? Yes? So what we had to do last class is we had to try and use the methods from 11.7, but the methods of 11.7 required that our function be a function of two variables, right? So what we did is we took this and we solved it for z, which gave us this ugly square root, and we replaced it in here, and then we had a function of two variables, and we were in business. And it was a nasty derivative, and the algebra got ugly. What I'm here to show you now is that this is perfect for Lagrange. We have a function, f, we'll call it f even though it's v. This is f of x, y, z, yes? But that x, y, z just can't be any x, y, z. It's constrained, right? The x, y, z must live on this ellipsoid. That's the constraint equation. Understand? I want the maximum of this constrained to this. This is our g. Oop, overshot that a little bit. That's our g. So let's try and set this up. What would the first equation that we have to solve be? Oh, it was 8. Thank you. Yes, it was an 8 in here. I'm glad you reminded me of that. It was 8 because the xyz was just in the first octant. Thank you. So what is the first equation we're going to have? Because we're going to have 4 of them. Pardon?
Do we have to consider that?
Have to consider what?
In this situation?
The 8?
The 8.
It's not, the x, y, and z that make it the max will be, the 8 won't matter. The actual maximum volume, we need the 8. But to get the x, y, z, it wouldn't matter. But it says, see, it says find the volume, though. So if you left the 8 out, just remember to multiply it by 8 at the end, yeah. OK, first equation is the partial of this one with respect to x, right? Which is 8yz equals the partial of this with respect to x, which is, and then lambda, 18 lambda x. Yes? Second equation is 8xz equals 72 lambda y. Y'all with me? Third equation. 8xy equals 8 lambda z. Fourth equation is the constraint. Okay. 4 equations, 4 unknowns, x, y, z, and lambda. What do you want to solve for? My goodness, that looks crazy. There's different methods you could use here. But I want everyone to notice something. 8yz, 8xz, 8xy. Those are almost the same thing, aren't they? Like, if this was 8xyz, and this was 8xyz, and this was 8xyz, then they would all be the same, wouldn't they? And I could set them equal to each other? So how would I make this one 8xyz? Multiply both sides by x. But then I have to tell you, make sure that what? X is not 0, right? Now, am I going to be concerned about that? Like, am I going to need to go back and check it, what about when x is 0? Yeah, you would, but think about your volume. What's your volume if x is 0?
0.
So who cares? We know that that's not going to be a point, right? We know that that's not going to give us a maximum volume. So same thing with y. What if I multiply both sides by y here? Then I have to say, suppose y is not 0. But if y is 0, then I'm stupid to be looking for maximum volume when y is 0. What about here? Multiply both sides by z. Z can't be 0. Well, I hope not, because then no volume. Understand? So I'm going to quickly eliminate the whole idea of x, y, or z ever being 0. All right? Who cares? So I'm going to multiply this by x, which gives me 8xyz equals 18 lambda x squared. This equation, I'm going to multiply everything by y, so 8y xyz equals 72 lambda y squared. And then this equation multiplied by z, xyz equals 8 lambda z squared. All right. Now, if these are all 8xyz, right, then I can set any two equal to each other. So how about setting this one and this one equal to each other? How about that? What if I do that? What if I set 18 lambda x squared equal to 72 lambda y squared? How about we move everything to one side? 18. Do y'all know where I got this from? Yes? Everyone okay on that? No? Yes? No? This and this are the same, so I'm setting this equal to this. So this is 18 lambda x squared minus 72 lambda y squared. Factor out a GCF. It's the biggest number I can get out of there. 18? Lambda? What am I left with? X squared minus 4 y squared equals 0. What are the two possibilities here? Lambda is 0, right? Lambda could be 0, or what? X squared could equal 4y squared. So I could set that equal to 0. Now I'm going to have to look at both of these scenarios. But I'd like for us now to just think about this. Look at equation 4. Do you see I can replace x squared with 4y squared? Maybe there's a way that I can get this z out of here and put y's in instead. So set which ones together? This time, set this one equal to this one, because that has y's and z's, right? So I'm just saving my thought right here, and I'm going to now set those two equal to each other. 72 lambda y squared equals 8 lambda z squared. Move everything over to one side again. 72 lambda y squared minus 8 lambda z squared equals 0. Factor out a GCF, which would be 8 lambda. And you're left with 9y squared minus z squared, which would mean what two things for you? Lambda is 0 or 9y squared equals z squared, right? Okay, let's go and write equation 4. Write equation 4 down. We're going to let x squared be 4y squared. We're going to let z squared be 9y squared. So from equation 4, we have 9 times, what's 9 times x squared? What's that going to give us? 36y squared? Plus 36y squared again, plus what is 4 times z squared? And 4 times z squared is 9. So another 36y squared must equal 36. Which means we can, what, just divide everything out by 36? So 36s are gone. Those turn into 1s. 1, 1, 1. So you get, how many y squareds on the left? 3 of them. 3y squared equals 1, which means y equals plus or minus the square root of 1/3, which is plus or minus the square root 1 over root 3. Which we only have to look at the positive. Because if you remember when we were doing the problem, the x, y, z that we were picking was in the first octant. So all the coordinates were positive. So all we have to do is look at the positive case here, okay? If I know what that is, if I know what y is, can I get x? Yeah. Just square that. Square it. What do you get? 1/3. And then multiply times 4. 4/3, then take the square root. So we'll be back at 2 over root 3. I know I'm working quick because we're almost done with this. And we're almost done with class. So from that information, this right here implies that x would have to be equal to 2 over root 3. And finally, you could get z. What would z be?
If you square that, wouldn't that be just 3 on the bottom?
Well, hold on, because what we're doing is we're going 4, and then what's y? It's 1 over root 3? But then you're squaring it, right? That's what x squared is. So that becomes 4/3, but then square root again, and it goes back. What is this? What is it? 3, root 3. So it looks like 2 over root 3, 1 over root 3, and the z coordinate root 3. I don't want to put you on the spot. Do you remember if you got that? You did get that? So I don't know if you think that was quicker or not.
Yeah, it looks like it was quicker.
Yeah.
A lot cleaner.
Lot cleaner. Lot cleaner.
Is it because of the, when you were talking about we only look at the positive because it's in the first octant, could we just say because the volume couldn't be negative?
Yeah, same thing. That's why we were saying first octant. Yeah, because we don't want to go negative volume. Now, we did need to look at, what if lambda is 0? But if lambda is 0, look, if lambda is 0, this is 0. And that means this is 0. And that means this is 0, right? Or even better, you go up to this one. 0 here, 0 here, and 0 here. So look at this. What does this mean? Either y is 0 or z is 0. And if y is 0, you have no volume, right? Who cares? Here, same thing. So lambda being 0, although there might be some values, it's not going to be a maximum. So within the context of the word problem, it wouldn't make sense for you to go look at those. All right, well, we have 5 minutes. I think this is a good time to cut off. The homework assignment for this one is, I think it's incorrect. That's not even the right page. Yeah, that's not supposed to be there. So that's supposed to be... And I have not done these. I started working on these the other day. I just haven't gotten to them. Anyone want to tell me what page? Oh, wow. Oh, yeah. Hold on. That's correct, probably. What I meant was the 11.8 homework. we will do some more.
Yeah, for the first time.
We will do some more. But please, if someone could check, does anyone have their book? 683? Yeah, 683. This should be just 1 through 19 odd. So I have like 2 minutes left, right? For any of you who actually use these interactive CDF players that I've made, I know you use them, right? Someone does? Does anyone? Because if no one does, I'm not gonna, okay. If anyone, I actually put something here at the end that you may find useful sometime later in your life. I made these calculators where you can put in, like the problem we just did a second ago. Remember where we had that plane? F of x was 4x plus 6y. It was constrained to that circle, x squared plus y squared was equal to 13. If you type the function in, the constraint function, and then the constant, and then you go and you hit this little U button, this program will actually go through and find your optimum solutions, your x, your y, and your lambda. It'll actually do it for you. And then if you want to do it where you have a function of 3 variables, this is the problem we just did. Wasn't that the volume? Wasn't that the volume right there? 8xyz. Wasn't the ellipsoid 9x squared plus 36y squared plus 4z squared equals 36? And you go through this and look at, I mean, it's spitting out a bunch of shit here, but it's giving you a bunch of the zeros. And see, it doesn't know that we're positive or negative, so it gave us some negative values in here. But this is the one right here. Where is it?
9.23.
Oh, yeah, because these are both negative, that would work also. There's more answers. There it is. This one right here is the one that makes the most sense to. Oh, no. Where is it? X, Y, Z, all positive. I'm missing it.
I think it should be the last one.
Yeah, the last one has that x equals negative 2.
Yeah, it's probably that. But it's
Huh. You know, there might be something in the code that prevented it from doing that. I can go back and look at it. I might have limited the number of answers it spits out. I don't even want to see this code. It's been so long since I wrote it. I don't even remember. It's not that much. Okay, well, either way, it's pretty good, okay? I mean, you can tell it was a little off. What we're going to do next time is we're going to realize that there's a way we can use Lagrange when we have a function of 3 variables with 2 constraints instead of just 1. Yes? Oh, yeah. So what are we going to do for the midterm as far as note cards or cheat sheets or whatever? Okay, you have the formulas that are off of our website, right? Those pages, no? In Canvas, the standard calculus formulas. They're 8 pages. Just check Canvas. I'll put them up there after class in case they're not there. Standard 8 pages of integrals and derivatives and trig stuff. I'm just trying to decide, do I want to reward you, give you bonus for not needing any note cards, or penalize you for needing them? Okay, then here's the deal. 1 sheet, front and back, formulas, steps, procedures, no worked out problems. Okay? So you may have the formula sheets that I will provide you. Okay. In addition, one sheet of paper, front and back. You can write whatever you want. No worked out problems. Formulas, steps, procedures. That's it.
Do you have to write? Can you like write on something and print it?
Oh yeah, you can. Yeah, you can like do. Just don't come in and be like, I need a magnifying glass to see this. Can I have my magnifying glass? Because you have to be able to read it yourself. Okay. So everybody gets that. If you don't use a formula sheet, then I will reward you. I don't know yet. Let's see how many people don't need them. Like if you're the only one who doesn't use a formula sheet, I will reward you more than if all of you do.
What do you want? Like it's 5 points.
Take it or leave it. I'm not telling you how much. Yeah. Okay? Everyone clear on that? One formula sheet. That's it.
I did all 40, and then you got like +6.
Y'all have a good day. I will. Yeah, I'll be in their normal time, which is 9 till, I think my first class is at 11. Yeah. What do you mean? Well, on Wednesday again. Are you saying like tomorrow afternoon, or are you saying no more?